Okay, let's go to bisection method. So the bisection method, which is alternatively called binary chopping, interval halving, or Bolzano's method, is one type of incremental search method in which the interval is always divided in half. So if a function changes sign over an interval, so the function value at the midpoint is evaluated. So the location of the root is then determined as lying at the midpoint of the sub-interval within which the sign change occurs. So the process is repeated to obtain refined estimates. So table below is an algorithm for the bisection calculation. So it states that step 1, choose lower x, l, and upper xu guesses for the roots such that the function changes sign over the interval. So this can be checked by ensuring that the product of f of x l to f of xu is less than 0. So xl and xu is the bound. Xl is the lower bound and xu is the upper bound. That is the boundary. Kung asa nang kuhaon ang roots, or that's the interval between the 2 points. So step 2, an estimate of the root xr is determined by xr is equal to xl plus xu divided by 2. So kuha lang average sa lower bound and the upper bound values divided by 2. Then for step 3, which is ito yung medyo mahirap-hirap or matrabaho. So make the following evaluations to determine in which subinterval the root lies. So for the product of f of xl to the f of xr must be less than 0. So if that's the case, the root lies in the lower subinterval. So therefore set the upper limit, which is equal to xr, and then return to step 2. Okay, I'll explain that later. So letter B, if f of xl, product of f of xl and product of the root xr is greater than 0, so the root lies in the upper subinterval. So therefore set xl, which is equal to xr, and return to step 2. Okay, so in letter C, if the product of f of xl and f of xr is equal to 0, the root equals to xr. So terminate the computation. So okay, so for step 1 daw, so ang gagawin daw natin is kukunin natin yung product ng the lower and upper bound. So dapat it must be less than 0. Okay, kapag nasatisfy natin tong equation na to, go to step 2. So compute natin yung average, kukunin natin yung roots or the estimated roots by computing the average of the lower and the upper x bound divided by 2. So after natin ito makuha, kunin natin yung product ng f of xl multiplied by the functions of the xr. Then, kapag ang lumabas is less than 0, okay, less than 0, so ang iyong upper bound limit x is equal to the xr. Ito yung original na na-compute mo sa step 2. Then, your new xr, so compute mo na naman yung bagong xr. So that would be the lower bound xl plus xr, itong pinakauna, divided by 2. After which, compute mo na ang bagong f of xr new. Ito na yung xr new. So kunin mo yung value ng f of xr new. Okay? Then, kapag ang lumabas ulit, nakuha mo na yung FXR nyo, no? So, kunin mo ulit yung product nung uh, X of L, lower bound, saka X of R new. So, pag ang lumabas na ulit na condition is same gihapon na less than 0 gihapon siya, so ulitin mo na naman yung process. Okay? So, kukompute mo na yung bagong XR. Okay? Then, ulit na naman ulit, compute. Pero pag during your computation, ang lumabas na is greater than 0, so ito na ngayon yung gagawin mo. So, yung lower bound XL is equal to the XR, yung original na XR. Then, you will compute for the new XR. So, using this equation. So, XR old, ito yung original or old, plus the upper bound, ito yung original na upper bound, divided by 2. Then, compute mo ulit yung functions of XFR new. Then, check mo ulit yung product ng lower bound sa X of R na new. Okay? Kapag ang lumabas is greater than 0 ulit, so repeat the process na naman. Ganun ulit, same process. Until such time na dumating na yung product ng lower bound to the roots is equal to 0, so wala na, tapos na. Wala ka nang gagawin. So, ibig sabihin nun, yung roots na yon is equals to the XR. So, yun na yung roots. Okay? So, let's have some example so that you can understand the steps mentioned for bisection method. So, using bisection method, determine the drag efficiency needed for a parachutist of mass M. So, this problem is almost similar to the graphical methods. So, but now we will use the bisection methods. Okay? So, ito yung problem kanina sa graphical methods. So, yung first step na sinasabi kanina, so step 1, choose lower XL and upper XU. Guesses lang for the root. Okay, let's check. So, let's say ang XR natin ay 12 and XU natin ay 16. Bakit? Kasi ito yung point kung saan nag-change na siya ng sign. No, nag-change na siya ng sign. So, let's say lang, kunyari, hindi natin alam na dyan nag-cross. So, let's choose the lower bound as 12 and the upper bound as 16. Okay. And now we will compute step 2 for the value of check muna natin kung ang f of x, so that is f of 12 times f of 16 must be greater than 0. So, ganito yung gagawin natin. Teka, First, mag-try tayo dito. Alagyan natin kung ilang trials. So, trials. Then, let's put the value of XL, the lower bound, and the upper bound XU. Then, let's compute for the value of f of XL. Then, the value of X upper bound. Okay, so from there, we can compute for the value of XR, then the functions of XR. Okay, so that's it. So for the first, pinakauna, yung una natin in-estimate na lower bound sa problem is ano nga yan? 12. So lower bound is 12 and the upper bound is 16. Okay, how will we compute for the value of f of xl? So let's go back to the previous problem. Sa bracketing method. Ito. Sa graphical method. So, ito yung formula na gagamitin natin. So, ang lagyan natin ng value sa C is katong XL na 12. Value of C is 12. Then, sa upper bound, kung ilan yung 16, F of 16. Okay. So, let's go back. We will solve the problem. So, okay. So, nakopy natin. So, that is equal to 668.06 divided by C, which is XL, 12, times 1 minus E raised to C divided by M times 10 minus 40. Okay, so it will give us the value of f of x of L is equal to 6.113877. And for the f of xu, so follow lang nato ni f25 1 minus 2 f of 25, so that is negative 2.230. So what is the value of xr? Xr is the average of xl plus xu divided by 2. Okay, so that is equal to 14. Okay, for the f of x of r, so i-copy lang nato ang problem. 12c 12b, but we will change the value of h25 to i25. Okay, so that's the value of f of x of r. Okay, so what's next? Step 1, kung ito ang product sa lower bound and the upper bound. Then 12b. Okay, so kung saan nato ang product. So let's check lang nato nga dapat siya ay less than 0. So xl times so that is negative 13, so that is less than 0. So okay ta diha. Then dito sa step 3, function of x of L times f of x of r. So that but daw is asa man siya, less than or greater than 0. So nag-greater than 0 yung value ng product ng f of xl and f of xr. So ang ibig sabihin, xl is equal to xr. So we will compute for the new value of xr. Okay, so how will we do about it? So there's an if conditions. Okay, asan na yan? Ito. for step 3. So, na yung mga if condition, no? So, we will compute. Okay. So, the condition would be is equals to if condition. If. So, ano yung if natin? If XL, the product of XL, 2XR, so product ng XL times XR is greater than 0. Ito yung first, greater than 0. Ano nga mangyayari? Then, the value of XL would be what? Then, XL would be equal to XL. XL. Or else, it is equal to XR. Close. Enter. Okay, so that's 14. Now for XU, so tanggalin na lang natin to para hindi pampagulo. Then for XU, it equals to if f of XL times f of XR is what? Greater than 0. Ano ang mangyayari? Yung x of u is equal to original x of u or else x of r. Okay. Now we compute for the value of f of x of l and the f of xu. So let's just copy here. Okay. Then we will also need to calculate the approximate error. So, anong error yung gagawin natin? Yung sa XR. Okay. That is the okay, for the error, that is equal to current value minus the original value divided by the current value times 100%. That is the error. So let's just reduce it. Okay. So now we will repeat the procedure again. XR. Okay, we'll just copy this for the third trial. Let's see. Control C. Okay. 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 And so for the problem, note that the true value of the root is 14.8011. So That is the true value. Which almost the same sa na-compute natin sa using the graphical method. So now, how will we stop? So we will compute for the true error. True error. So we know that the true value of the roots x are true is equal to 14.8011. Okay, so that is equal to uh, true value minus the approximate xr divided by the true value times 100%. So, kung natin siyang absolute value lang ang i-compute niya, so that is up to 3 decimal. Okay, so next, drag lang sa nato, but kailangan natin ang L22 na ka-dollar sign para fix. Okay, then i-drag lang nato siya. Okay, so the true value is 14.8011. So this part, so that is almost the same na. So true error natay 0. So di ba dapat ang sa error computation is the approximate error. So yung condition natin sa error is dapat ang approximate error must be less than the significant error. So in this portion, EA is still greater than the ES. EA approximate error. So what do you notice? So this is ikapilang trials yung may value ng 14.8. So on the 6th trial, so nandun na yung value ng 14.81. So how will we terminate? So we have the value of the approximate error 0.42 is already less than or below the threshold of 0.5% ES. Okay, so trial 6, so terminate na natin siya. Delete.
Who's that boy?
Then dito sa 6 trial, so na-meet na natin yung 14.8. So that's we will terminate the computation. Okay. Okay, so that's it for the bisection method. So below figure we have the some algorithm of the for bisection method. This is for Excel BBA language. So the algorithm employs user-defined functions to make root location and function evaluation more efficient. So in addition, an upper limit is placed on the number of iterations. Finally, an error is checked. It's included to avoid division by 0 during the error evaluation. Okay, so we'll make this algorithm sa Excel BBA macros and then try it to run. So this will be your plate number 2. Okay, so that's it for today. So we will continue next meeting for Newton-Raphson method. Okay, so goodbye.